We couldn't appreciate the complexity of the reinforcing and the density of the reinforcing in 2D in plans.
The model allows us to really dive in and sit around a table and look at those elements, look at it in a huge amount of detail, pull it apart and look at it from a buildability point of view. When you look at a 2D set of plans or maybe a section, you don't see everything that happens in that space. You're only seeing a physical single line cut. The 3D element really brings it to life.
So having this modelled for us by our subcontractor Steel and Tube in 3D is allowing us to identify how much deformation or cranking we need to provide in the heavy 25mm bars and assess which sections are best for prefabrication and which are for post or in situ fabrication.
We can actually prefabricate the reinforcement, and we can get, crank bars and lap bars and everything is done. So the guys, that's why they are able to come here on site and build it outside the formwork. So it avoids them working in there or trying to jump inside the formwork and inside the shutters.
There's some big bars in there that we've got to, that they're getting manhandled. They're not exactly light. There's a lot of stirrups, there's a lot of tying. So if we can get full access 360 around it, we can, once it's prefab, we can plonk into place and put spice bars through.
The other thing that we're trying to get to work now is bringing in line the modelling of drainage through the foundation beams by our services contractor, David Brown. So they're modelling in Revit and we're bringing that information into our federated IFC model and sharing that information so that the penetrations in these foundation beams can have bespoke detailing created for them ahead of time. And the idea being that we can create these sort of structural windows for penetrations and ground beams and do that on the stand, on the jig, rather than having to crawl around in the forms and create these penetrations, dragging extra stirrups and lap bars and that into it post. The more that they can pre-tie or tie in a controlled environment on stands reduces the sort of manual handling aspect of it on site. So if they're only tying in lap bars and corners rather than trying to tie a whole cage in situ, is a manifestly better result for them.
So if we get that right in the model, we get it right on the shop drawings, we get it right in the manufacturer, and we get it right on site, and then all we need is just a crane and lift all the cages that are ready, place it inside the shutters, and hopefully, by Friday we are pouring all these beams in. The big advantage of using the BIM, you can plan how you're going to do it on site, how you're going to build it. You can do a little bit of programming, and through that we can also check what's the safest and easiest way to build it.